The period is 2 pi square root, and then I believe this is m over k. Let me just go confirm that here. Yep, m over k. So in each of these, you're known as m, your k is known, and your unknown is t. So we're just using this. We're just using this formula here. So you're gonna basically just repeat for each one your mass. Like for example, the first one, it's in the wrong units. That's it should be in kilograms. So it's 0.2 kilograms. This is 0.35 kilograms. It's 3.175 kilograms. So we're just going to want to use those values, and then your n's in the right one here. So just want to get this into your calculator. 3 different calculations there for it.
That's good.
So let me get some numbers for you here. All right, so 2 times pi squared times the square root of 0.2 divided by 15. And we got 0.726 for the first one. The next one, enter that again, 0.35 for the mass, and the 35.5 for the K, and that's 0.624. And last one here. So notice it doesn't necessarily have anything to do with like one quantity or the other, especially when they're both changing. This is 1.001. Okay, so the longest period is obviously this last one here. It's the biggest number. The shortest period is the middle one. Doesn't ask for that. All right. Moving along here to number 5. Number 5 here. Snip that in. All right, you're designing a grandfather clock to have a period of 2 seconds. Your period is 2. How long should the pendulum be? How heavy should the pendulum bob be? Okay, we're trying to find the L, and there's 2 different formulas that they give you for period. One of them is has just L, and T equals 2 pi square root L over G. When you solve this for L equals T squared over 4 pi squared, and then G goes up top. Oops. And you have all these quantities. You have 2 squared times 9.81 over 4 pi squared. So just get those into the calculator.
I get 0.99. What did you get? If you're talking, you're froze for me because I can't hear you. Unfortunate. Hello, hello. Do you hear me? You're muted for me.
Hey, Jack.
Just
Jack,
about
you still there?
internet issue. Hello.
Hey, yeah, I have no idea what happened. Doesn't really matter, but we are back.
You just kind of froze for me, and I was like,
Yeah,
okay.
it disconnected. So are you seeing my screen now with
I
this?
sure am.
Okay.
So I got 0.99, which is basically
Yeah,
one.
and I see it. I got that as well. The what this question doesn't give, and I'm not sure how to do it, is to do this you need to know the K, which we don't have. So not really sure. Not really sure how to answer part A. How heavy should the pendulum bob be? So we might have to skip past that. Is that okay? Because I don't have,
Yes, it is.
not all the information is there, unfortunately. Okay. 6. We should be through this another, I don't know, 8 minutes. And then we can move on to some math.
That's good. I'm going to send you some worksheets after that.
All right. Here, they tell you that the period is 12 seconds. What is the height of the building? So it's like you're trying to find L, which we all of these are like one variable equations. Period equals 2 pi square root L over G. L is equal to G T squared over 4 pi squared. Your G is 9.81. Your period is 12 squared over 4 pi squared. So give that a check. See if you can see what you get for that. 9.81 times that divided by. All right, so that's 35.8 meters. Just about 100 feet, maybe a little over, but that's kind of reasonable.
Sounds good.
And 7 is our last one here. All right, when a mass 25 grams, that's already in the wrong units. It should be 0.025 kilograms divided by 1,000. It's attached to a certain spring. It makes 20 complete vibrations in 4 seconds. So 20 vibrations in 4 seconds. So that means it makes, if you divide by 4, it makes 5 vibrations per second. And so that's the whenever it's 1 over s, this is frequency. So you flip this, so it becomes 1 over 5 seconds. That's 0.2 is the period. So the reason we need to do all that is to be able to answer this question. We're trying to find K, and we know that the period is 0.2. We also know the mass is 0.025. The formula T equals 2 pi square root, I believe it's G over K, M over K, it's M over K. So to solve this for K, M equals T squared over 4 pi squared, or M over K equals this. So K equals 4 pi squared over T squared, and then M over here on the top. So we have all those quantities. 4 pi squared. We know the mass is 0.025 kilograms. The period is 0.2 squared. So you can do that. 4 times pi squared times 0.025 divided by 0.2 squared. So K ends up being 24.7 newtons per meter. All right, that closes out that worksheet. Whenever you're ready, I guess send over.
Oh my god, I thought I was muted. I'm gonna send you that right over.
Great, sounds good. I'll look for it.
Should be sent. It'll show up in your email in just a second.
Got it. So we got a worksheet, and I'm opening it up now. Okay, so this came in okay. Do you need to work through all of them, or just certain ones, or what's the plan here? Jack, yeah, you're currently muted. Just want to know which one. Yeah, which ones do you want us to work through? All of them, some of them?
I would like to work through at least 5.
Okay, but you do like sometimes you said only do the.
Just kind of like this one isn't just like do only the odds. This one you can do all of them, but I'd like to cherry pick a few of them.
Okay. All right. So number one here, there's all these different approaches, and one of the approaches here is to rewrite everything in terms of sine and cosine, only sine and cosine. So like secant is 1 over cosine. Now, one of the things I do that you really shouldn't do is I tend to not write it with the letter for speed. I'll try to remember to add that in. Tangent is sine x over cosine x times sine x. And then you only work on one side. So I'm choosing to work on this side. You don't work on both sides most of the time. So do you see that these have the same bottom, the same denominator?
Yes, I do.
You can combine them. So the top becomes 1 minus sine squared x, because sine times sine gives you sine squared x. Okay.
Okay.
Another strategy you have are identities. So the one you're going to use most often is sine squared x plus cosine squared x equals 1. And then generally it's like 1 minus sine squared x equals cosine squared x. That's one way to use it. Or 1 minus cosine squared x equals sine squared x. So in this case, you're going to replace all of this with what?
You're gonna wait. What?
You're replacing all of this with cosine squared x. 1 minus sine squared x is cosine squared. So the top becomes cosine squared x over cosine x. Those cancel. So you're just left with cosine x.
On top, right?
On the top. The bottom is 1. Now you might be thinking, well, how do I get, because if I had bring down this other one, it's 1 over secant x.
Mm-hmm.
Well, cosine can be rewritten as 1 over secant x. That's a reciprocal identity. Okay, but your instructor is looking for everything down the left side. Like you have to do all of those. You have to show all those steps. Think back to geometry when you did a bunch of proofs.
Fair enough.
Kind of the same deal. Okay, let's go look at number 3.
Let's do it.
All right, number 3. So you have to decide which side you're going to work on. The left side is more complicated, so you're going to work on the left side. Just going to rewrite it here. Okay. So again, kind of one of the tactics here that you will use pretty often is when you're writing, whenever you see a 1 plus or a 1 minus, you always multiply by the conjugate. 1 minus secant theta, 1 minus secant theta. And the reason is because on the bottom, I'll just focus on the bottom for the moment.
Mm-hmm.
The bottom becomes an identity. It becomes 1 minus secant squared theta. Now I've sent you that trig sheet before. Do you have access to it right now, or do you want me to send that to you here through the chat?
Let me see.
Actually, I'll just
I should have
snip.
that.
You should. Yeah, you should have. Let me also just snip it in because these are. I sometimes forget I can do that because we only need these three.
Okay.
So there's 3 Pythagorean identities that you need, and the one that we're using here, it's this middle one. But you might be saying, well, it doesn't look like the middle one. Well, it does if you move things around. Okay. Like this middle one here, you can rewrite it as 1 minus secant squared theta by moving this to the left, but then you got to move the tangent over, so it's minus tangent squared theta over here. So this becomes sine theta plus tangent theta times all of this times 1 minus secant theta over minus tangent squared theta.
Mm-hmm.
So sometimes these get worse before they get better. That's the case here. All right. So not really anything obvious to do up here. I think we'll multiply in. So it's we're going to FOIL the top. So it's sine theta. That's the first. The outer is minus sine theta secant theta. The inner is tangent theta. And then the last is minus tangent theta secant theta. Kind of still doesn't look any good. We'll get to that. Now you can write everything in terms of sine and cosine.
Oh, really? How?
So sine theta minus sine theta. What is secant? It is 1 over cosine theta plus, I'm going to actually leave tangent theta alone.
Is it cosine on the top? Oh, never mind.
And then this tangent theta is sine theta over cosine theta times 1 over cosine theta. So we'll get to that over minus tangent squared theta. Okay, so now you have to see that this is sine over cosine is tangent, and that's tangent. So do you see how those cancel?
Yes, I do.
Okay, so this top becomes sine theta minus sine theta over here over cosine squared theta over minus tangent squared theta.
Yeah.
So you have a choice here. We can either multiply everything by the reciprocal of tangent squared, or we can make a common denominator up here.
Okay.
So we'll just make a common denominator up here at the top. So we multiply top and bottom by cosine squared theta. So this produces sine theta cosine squared theta minus sine theta all over cosine squared theta all over minus tangent squared theta. Now, tangent squared theta is really sine squared theta over cosine squared theta. Now, whenever you have a fractions, whenever you have like an a over b over a c over b, becomes a over c. These cancel. So you get sine theta cosine squared theta minus sine theta over minus sine squared theta. Now we're really making some progress here. So this negative, we'll deal with that in a bit. This sign and this sign, you could factor a sign out from both of them. That cancels with this one. So that sign cancels with that sign, and you're left with cosine squared theta minus 1 over minus sine theta.
Wait, how minus 1?
Well, there's if you factor a sine theta out, you have a 1 here.
Okay.
Okay. What are we supposed to? Sometimes I go deep in these things. I don't even know what we're looking for. Oh, just sine theta. Okay. So now we can use a property again, sine squared theta. So this negative can go up here, and it changes the order. It becomes 1 minus cosine squared theta over sine theta. And we know that sine squared theta plus cosine squared theta equals 1. So 1 minus cosine squared theta equals sine squared theta. So that's the top. It becomes sine squared theta over sine theta, which is just sine theta. And that's what we're trying to get to. Perfect. Might have been faster to go down another road, but these all sort of are are the same. Okay, let's do 5.
Yes.
And then for 7, 8, 9, I have no idea what it's referring to. You won't know what that means. Rewrite, but we'll get to that. Okay. This one, it's kind of like, well, I don't know which one's more complicated, the left or the right. One thing's for sure though is because we're doing squareds, we're definitely going to be using some variation of this. Sine squared y plus cosine squared y equals 1. By the way, this letter can always change. Like sometimes it's theta, sometimes it's x, doesn't matter. Okay. The fact that it's 1 though suggests that we're probably doing something for this, because this one has a sine squared and this one already has a sine squared. So let's solve this for cosine squared. Cosine squared y is 1 minus sine squared y. So this right here is 1 minus sine squared y minus sine squared y. Well, what do these combine into?
Just
minus 2 sine squared, and we're done. So they are sometimes that like straightforward, simple, not too many steps. The previous one could have been done. Go ahead.
Okay. I still understand the cosine thing, just simplifying out, because it equals 1 minus sine 2x. Sine squared x.
We're substituting for that. Like everything in here is that.
Okay. That's straightforward. My bad. I forgot about this over the summer. Good to revisit it.
This is very much a pencil and paper operation. They don't do it well on web stuff like they. But okay, 7, 8, 9. Do you have either the answers or?
Oh yeah, I do have the answers to this. She gave us.
Do you have an answer for any of these?
Excuse me. Let me check. On
that way I can give you a.
Number 7 is just negative sine 2.5.
Okay, so here's what your instructor is she's saying sine of minus x equals minus sine of x. So what that means is the negative in here comes to the outside. That's why this is rewritten as minus sine 2.5.
All right.
We'll go to 9 next. Cosine of negative x equals cosine of x. And that's because this is an even function and this one's an odd function. That's the reason. So this negative essentially goes away. This is cosine of 2.35. You're just rewriting. They're not asking you to
mess around with it too much.
Yeah.
All right.
All right, now this one over here is cosecant. Cosecant is really 1 over sine minus 1.52.
Okay.
So this becomes, just from the first one there, negative 1 over sine of 1.52. All right. Well, I mean, if this is all you need to go through, we should just go back and do, well, we should do maybe 10 or 11, but then.
Go back to one of the others.
We have plenty of time, I guess is what I was trying to say.
Number 4 looks pretty complicated.
Okay. All right, so number 4, it's you have to decide which is the more complicated side. I think the left side is clearly more complicated. Because there's no squares, you're generally going to rewrite everything in terms of sine and cosine. So like secant is 1 over cosine theta over cosine theta. Tangent is sine theta over cosine theta. Cotangent theta is cosine theta over sine theta. So sometimes you have to do these problems where you take a step and maybe it's good. Sometimes you take a step and it's bad, and then you got to backtrack and make the other step. We're gonna combine these. So If it isn't clear, you're multiplying the top and bottom to get rid of this cosine theta. You're multiplying the top and bottom by 1 over cosine theta here. And that produces a 1 over cosine squared theta. On the right here, this is sine theta over cosine theta, sine theta over cosine theta. And in both cases, let's see how the bottoms cancel.
Yeah, I do.
Minus sine squared theta over cosine squared theta. So notice that these have the same bottoms. So you can write this as 1 minus sine squared theta over cosine squared theta.
All right. Do we do any more with that?
Absolutely. So the main trig identity you're using is the sine squared theta plus cosine squared theta equals 1. Here, you have to start seeing that it's not just this. It's really 1 minus cosine squared theta equals sine squared theta. That's one way to use it. Or 1 minus sine squared theta equals cosine squared theta. So in this case, we're gonna replace this with cosine squared theta. Keep the bottom, so this becomes 1. Okay, is that there probably is still some confusion about this stuff on the right, but it's like saying A plus B equals 1. So 1 minus B equals A, or
and
1 minus A equals B.
Oh, so that's
all it is.
I understand it now. Okay. All right. Let's move on to another one. Do you excuse me, is there one that you think you personally think that we should go over real quick?
I mean, we have time to do all of this, that's what I'm asking. If you want to do anything other than this worksheet, you should
have a little what is it? One of those little quizzes things where I can take like a screenshot and send it to you.
Sure. I mean, probably have time to do those. Take about a minute per question, so might be able to finish it.
I'll be as quick as I can. Here we go. All right, let's get started. Print screen, apply, attach, screenshot at the end, drop, and sent. I have it open with me, so you don't need to like pull it in, like pull the snip in your photo.
Okay. All right. I'll try to talk through it. I'll try to do it verbally here. Okay. Well, so this one is like, since it's multiple choice, you could actually get a calculator and evaluate the left and see which one it evaluates to on the right. That would be one or see if see if which one of the 4 it becomes. I actually don't know. I have to calculate this, I guess is what I'm trying to say. So I'll do that for you here. I'll just give you the result. It's close to being an identity, but it's not an identity. There is one. Well, maybe it is. Maybe it is tangent A plus B. It's probably tangent 75 or 15. I'm not sure yet. Let me see. Oops, I didn't like that. Wow. Okay, so it's that number. I'm having interest in a calculator. Did I not enter this right? I assume the answer here is it's very important that you get the right answer. Tangent 45 plus tangent 30 over 1 minus tangent 45. Oh, that's why. Tangent 30. Okay. 3.73. Okay. All right, so it is tangent of 75. This is a sum or addition identity.
That's correct. All right. Let me send you another one. Here we go. Printing up. Not like actually printing it, just like a screenshot. It does like this. On my Windows key, it says I have to press Windows key and print screen on my top right the keyboard. All right, that one's sent. Should come in any second.
Your quizzes always seem to provide the most difficult ones first. Okay. The problem like this, it's either equal to the addition of these or the subtraction of these. If you have that cheat sheet out, you'll see that there's sum and different formulas on there for cosine, 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 sine, sine, cosine, cosine, sine, sine. It ends up being the opposite of that. So if you're adding there, you're subtracting there. So in short, looks like it's going to be the cosine of 85. I can confirm that if you need me to do that. But if you want the quick answer, looks like it's cosine 85.
Cosine 85?
Let me just verify that here. Yep, it is cosine 85.
That's correct. I'm gonna send you.
So I'm using the formulas and identities on the second page. There's sum and difference formulas. And if you want to look.
Sum and difference formulas. Oh, I pulled that up. All right. Where's the sum and difference formulas that you said?
On the right side of page 2, sort of towards the top, it's a sum and difference formulas. Sometimes they give you the right side, sometimes they give you the left side, and you got to move back and forth between them.
Oh, okay. Cosine 80.
All right, so there you see you send a picture. Expand. Okay, so this is kind of like it is what we've got there. It's sine, cosine, sine 33, cosine 42, and then it keeps the positive or negative. So then it's gonna be plus cosine. Is it cosine sine? I gotta move back and forth. Yeah, looks like it's the one on the left. Sine, cosine. Yeah, it's the one on the left. They're the more blue, less aqua.
So farthest left, is that what you said?
Say that again.
The sine 33 degrees, cosine 42 plus cosine 33 sine 42.
And you can see that that's the first sum and difference formula. When it's sine alpha plus beta, it becomes the plus in the middle.
All right, next one sent.
Okay. All right, there it is. Okay, so this is cosine, cosine minus sine, sine. That's the right side. That's the second sum and difference formula, cosine, cosine, sine, sine. If it's minus between those, it becomes plus in the other ones. So it's plus 75 and 15 added together, cosine 90 in this case is what it looks like.
Say that one more time.
It looks like it's cosine 90 in this case. So that's based on using the second sum and difference formula that says cosine, cosine, sine, sine. That's what you have, cosine, cosine, sine, sine. The minus between those becomes a plus on the left side of the identity. So that means you're going to add the two numbers together, 75 and 15, to
So
make
90.
90. But it's cosine of 90 in this case.
Wait, so what happens to the sign though? How do you get only one variable?
That's just the way the identities work. I'm using that.
You just get the stuff on the left, basically.
Yes.
Okay.
They work, right to left or left to right, depending on whether you're expanding or condensing
Sounds good.
them.
Attach the next one. Here we go. Attached. There.
All right, so the picture came in.
It's going to be just sine 230, cosine 230.
So it's a cosine, cosine, sine, sine. So it's that middle one. So it takes if it's plus between them, it becomes subtraction.
Oh, really?
So you take 175 and subtract the 55.
Am I doing it from the right sine?
It's following that middle identity. So that it becomes cosine of 175 minus 55.
Minus 55.
Cosine of 120.
Okay.
That's fine. That's fine.
Alrighty, I'm going to show you that next one.
All right, let me know when that next one. Maybe it's there, not yet.
Thank you for helping. I appreciate it.
Yeah, of course. You back in school or you hybrid? What do you guys got going on?
No, we're doing 4-day hybrid now. I get to go in person. Today was the first day of that for me.
Oh, good.
I really enjoy it.
Yeah, it's a lot better. Expand cosine of alpha beta. So this is the middle sum and difference formula, and it's going from the left to the right. So it becomes cosine, cosine, sine, sine. So you can see that's either the first and the third one from the left. Cosine, cosine, sine, sine. Now the plus, since there's a plus in there, it becomes a minus in the expanded formula.
Okay, so
that's just the way it.
The yellow one.
The one on the left here. I can see how we're struggling here. I'm not, maybe this, I should snip this in here.
Get an idea of what's going on.
Well, I guess so we're using the middle one. Okay.
Okay.
And in your problem is this one, your alpha is pi over 5, your beta is pi over 6, and you have a plus here. That plus goes to a minus here.
Okay.
But it's cosine, cosine, sine, sine.
Cosine, cosine, sine, sine. So we can immediately eliminate the middle left and the farthest right. So now it's between the yellow and the left blue.
Yes.
And we know that it's subtraction, so it'll be the farthest left.
Yes, exactly.
Okay, perfect. Much better. All right, pump the send out. Send in that next one. Here we go. Dropping it in and send. Use sum or difference angles identity to find the exact value for cosine 105 degrees. Is that basically just looking at the unit circle, or what is it talking about?
So 105 is not on the unit circle, but 60 and 45 are.
Okay.
Okay, so 60 and 45 are. So it's like you're doing cosine 105. So that's like doing the middle one there, where your alpha is 60 and your beta is 45. And when you do that, it does reduce to one of these. Now I can work through this or just give you the answer for this.
I'd like to work through it a little bit because I want to know what it looks
like. All right. So what I'm telling you is that your alpha is 45 and your beta is 60. So it becomes cosine 45, cosine 60. Because these add together, this subtracts, sine 45, sine 60. So now we need these values. Cosine 45 is square root of 2 over 2. Cosine 60 is 1/2. That's unit circle stuff. Square root of 2 over 2. Sine 60 is square root 3 over 2. Notice these always have the same bottom, so it's square root of 2 over 4 minus square root of 6 over 4. And that's where we get our answer, square root of 2 minus square root of 6 over 4.
Wait, so you're adding like the square 2 over 2 to 1/2 on the left?
You're multiplying. These are
multiplying. Okay.
Yeah, these are all multiplying.
Just making sure. I just want that to be clear. All right, so -2. All right, so 2 minus, which one would this be? Farthest left, it looks like to me. And that's correct. All right. Now we're on the last two. I'm going to send you these next ones. Right about here. But anyways, like in-person stuff is so much easier. Like my AP micro class was like 10 times easier, just being able to see the people, like, yeah, the instructor doing it, and then like other kids like chiming in. It's just so much better.
Yeah, I agree. Hope it can be
back to normal.
Back to the way it is. Yeah. So this is so this one here. Let me work through this here. So you got cosine 20, cosine 40 minus sine 20, sine 40. So this is your alpha, this is your beta, this is your alpha, this is your beta. Your book might use A and B. If you've gotten used to this pattern here, if we go back up, it's cosine, cosine, sine, sine. Notice that you've got a minus in the middle. The minus in the middle becomes the plus. So this becomes cosine 20 plus 40, which is the cosine of 60. Cosine of 60 is a known value on the unit circle. It is 1/2.
All right. Pretty simple. On to the last one here. And I'm going to send you this. All right. All right, should be sent. What do you do in this equation? Like when it's sine, cosine, cosine, sine?
Just another one of these identities that I'll copy in again. So what you just described, and I do see the email that came in there. It's the first one. It's a sine sum and difference formula, because you just said, hey, I got a sine, cosine, cosine, sine, sine, cosine, cosine, sine. So you've got a sine 100 cosine 20 minus cosine 100 sine 20. So that's your alpha, that's your beta, that's your alpha, that's your beta. It's this top one here. And you see that it's that top one? Hopefully you see that. So because it's minus there, that minus goes with that minus there. So this becomes sine 100 plus 20, which is sine 120. That is in your unit circle. It's equal to the sine of 60.
Wait, how does that work?
It's reference angles stuff, but you can also go to the unit circle and find it as well. Oh, it just wants that.
It just wants the sine 120.
Yeah.
Oh wait, that's whack. So that was incorrect.
Oh, it's mine. I'm sorry. These match. I guess that should have been 80. Okay.
Sine 80. Right.
Yeah.
That's correct. That's everything I wanted to work on today. I really appreciate your help.
Great. Sorry for the technical problems. And I'll send out the notes and screen recording here shortly.
Enjoy your evening, Matthew. Much appreciated.
See you next time. Bye now.